society has constantly changing from agriculture to industrial evolution. And now we are at the digital revolution where science and high tech has dominated our societies across the world. Therefore, I have created my mathematics channel with the hope that I can contribute to our global education. There have never been such a strong push for mathematics education across the world, especially in our North America. Therefore, I have created my math teaching channel online. As I said, I hope that my contribution will be beneficial to serve all the students across the world and contribute to our global education online. In this topic today, I would like to share with you one unit lesson in Recalculus Math 12, which is the transformation of coordinates. Because this topic have a lot of function notation involved, therefore I have created a PowerPoint presentation online with the hope that I can serve all of you so that it looks more attractive and it calls your focus more, and you will be patient to watch my entire video from the beginning until the end. Now this PowerPoint presentation online today will be a long presentation. I hope that on the information I have provided on my MS PowerPoint presentation is sufficient enough to provide you whatever key ingredients you miss in this lesson if you happen to learn in your school with all the distraction from your classmate around. And if you're sitting in the classroom of 20 students in the classroom, by some reason, it's not our teacher faults, it's not the student faults, but the environment we have in our public education will by somehow affect your learning focusing, and therefore I hope that my lesson plan will serve you well. So bear with me for the rest of my video presentation today, and allow me to share with you my PowerPoint presentation in the lesson of function transformation involved the coordinates transform. And because I would like to make this video is long enough, and so I incorporate in the video with my teaching video as well in my PowerPoint presentation. I hope that you will be patient enough to share with me this lesson online today. So bear with me, I will present to you my lesson online. So give me a second. I'm a little bit of informal today. So let me share screen with you. So just give me a minute to organize it. In this lesson today, we will examine about the transformation of the functions. In the first slides, you see we have many image of an orange triangle. This orange triangle can translate to the right or move to the left, translate downward or translate upward. This triangle can also be enlarged and horizontal shrinkle but vertical stretch, or horizontal stretch but vertical shrinkle. Next slide, we talk about the lesson 3 in the unit 1. So we move to transformations of coordinates. If we just look at the image, it might be simple, but when we talk about the coordinates and the way we calculate the new coordinates based on the function notation might be a little bit complex. So let's see what we learned. In this slide, you see we have a y equal f of x, which is the original function. The arrow shows you a new form of this function, and it is no longer this symbol. If you look at the y equal a times f times b bracket x minus c bracket plus d. So this is the combination of all the notation of all the transformation together. From this notation, you will identify vertical stretch by a factor of a, horizontal stretch or compress by a factor of b, horizontal move left or right by a letter of c, and the vertical shift up or down by letter D. For example, given the point M, N is on the graph of y equal f of x, determine the coordinates on the graph of y equal 3f minus 5 times x plus 2 minus 1 in terms of M and N. So let's make our observations. We see that in front of the letter F have a number 3, which is the indication of vertical stretch by a factor of 3, followed by a horizontal compress by a factor of 1/5, and move to the left by 2 units, shift down by 1 unit. So this is the reflection on the y-axis because we have a negative in front of letter B. And the result will come out as minus m/5 for the x coordinate, minus 2, comma 3n minus 1. So we multiply the y coordinate with 3 and take away 1 because we shift it down. For the x coordinate, we divide by 5 because remember for horizontal, we not divide by we not multiply by 5, but we multiply by 1 over b, which is 1 over 5. And therefore, we divide this x coordinate by 5, and then we'll take away 2 units. So that's how we calculate the new coordinate undergone this type of transformation. Let's check the next slide. In the next slide, there is another example here. You can look at it. Given the point M, N is on the graph y equal f of x, determine the coordinates on the graph of y equal a quarter f multiply half times x minus 4 plus 6. So in this slide, we examine, and we now should be familiar that the image, under the letter A and B and C and D here. So A stands for a vertical compress or stretch. B stands for a horizontal expand or compressed. C stands for shift left or right. D stands for shift up or down. And in this shelf, I show you, notice A. So from now on, when we talk about A, we should know that is a vertical stretch. So let's make observation of our new function notation. Our new function notation have a letter A equal 1 for a quarter, B equal 1 half, C equal 4, and D equal 6. So to apply the calculation to the coordinate M and N, what we should do is we multiply our x coordinate M by 2, then we add to 4, and we will divide our coordinate Y N by 4 and add to 6. So let's in the next example. Given the point x, y is on the graph y equal f of x, determine the coordinates on the graph of y equal minus f, 1 half x minus 4 minus 6. Now notice this. This is the complicated expression. So first, we have to factor out the expression so that we can identify the correct forms of the transformation. So I factor out here y equal minus 2f, open the bracket. We factor out the number 1 half in front of the x coordinate. And because we pull out this factor 1 half, so inside the bracket, we have to change the minus 4 become minus 8, because our 8 here divided by 2 will equal 4 back into the original. In mathematics, anytime we change the form of the number, value, or letter expression, we should be able to manipulate it in the way that we're not changing the original. So whatever the original is, when we factor out, make sure that when we distribute, we get back to exactly the same expression. And that's how we factor the expression. So let's take a look at the coordinate x and y. What do we do with the new coordinate? In this transformation, we know that for x, we have to expand by the factor 2 because 1 divided by 1 half equal 2. So we multiply the coordinate x by 2 and we add to a unit, because under this transformation we know the function translates to the right and not to the left. So we add, when it moves to the right, we add a unit in the x coordinate. Now look at the y-coordinate. We will multiply the y-coordinate by exactly the way it is, minus 2 in front here. And because we shift the function down by 6 units, so we take away 6 units of the coordinate y. This is the application of all the transformations. The result was shown above here. So this is the example 3. Now let's take a look at the next slide. The next slide, I show you transformations of an absolute function. So when you see the two linear side, a short form like this is the form of absolute value. And absolute value, it means if you have a negative 3 inside the absolute value, when you take it out, it becomes a positive 3 and it's no longer as a negative 3. Because absolute value means the positive and not negative. So given the point m, n is on the graph y equal f of x, find the coordinates on the graph of y equals 7f x minus 1 inside the absolute value plus 2 outside the absolute value. So we must complete on the transformation inside the absolute value first. So let's see how we do it. So first, if you notice, we don't have any effectiveness to the x-coordinate because we not translate left or right, we not move up, we not multiply with a factor of anything for the x-coordinate. So no reflection, nothing. However, we have an effectiveness on the y-coordinate here. First of all, we stretch the y-coordinate by a factor of 7. And then we, the function itself have shift it down by 1 unit. But then in a new transformation, it also shift up by 2 units, followed by the letter D outside here. So we have 2 letter D here, one inside the absolute and one outside the absolute. So minus 1 stands for the D letter. So this is the original function, but it's not based on the symbol 1. It's already shifted down by 1 unit. And then we shift it up later on by 2 units. So whatever we work in here, we should do exactly the order. So first we multiply the coordinate n, which is the y-coordinate, by 7. And then we shift it down, we take it away, minus 1. And we close the bracket, stand for the absolute value. It means whatever we operate here, when we take out the function, absolute function, we will add it into 2 units. So as a result, the new notation will become y equal 7f of x minus 1 plus 2. So this is, we analyze about the notation of the transformation. We haven't calculated the new coordinate yet. Let's take a look at another example about function notation here. In example 5, we have a function y equal minus 1/3 f multiplied with x minus 1 plus 8. And the first root inside the absolute value. So it means we will calculate whatever inside the absolute value here before we add the a unit into it. So now let's take a look at the example. So from the unit example 5, let's do the example 4 first. So in example 4, you will have m, comma, which is the x-coordinate, nothing change, For the y coordinate, we multiply with 7, we minus 1, then everything stay inside the absolute value. It means if you calculate this become minus, for example, if this operation give you a minus 4, then when you take out will be positive 4, add 2 becomes 6. So let's take a look at example here. The result for the example 5 will be inside the absolute value. We will move to the right 1 unit. So letter M will add into 1 for the x coordinate. For the y coordinate, vertical shrink by a factor of 1/3, so we divide the n coordinate by 3. However, we do a reflection over the x-axis, so we have to switch the sign. If it is positive, it will become negative. If it is negative, when we switch the sign, it will become a positive. And then everything, after we do that, then we take out the absolute value and we add into the 8. So let's see the next slide, what happened for the next slide. Okay, so in this slide, I am talking about the transformation applied to a rational function. So the past slide, we're talking about the absolute value function. Now we're talking about rational function. And a rational function have a form of a function. Just like in elementary, you have a function 3/4, 5/7. But in here, because we're in high school, we are in algebra, so our function involve not just the number, but the letter. So you have the reciprocal function 1 on top, which is the function, rational function, and then at the bottom you have an absolute value. So this function actually become both a function, rational function and absolute function as well. So we have the original function y equal f of x. Then now this function undergone a transformation of 1 over absolute value of f of x plus 5. Now make sure you notice that the number 5 here inside the absolute value, and it is a part of a denominator. Now in another example, you will see we want to calculate the coordinate 4 and minus 2 here based on this transformation, which is slightly different from the one on the top or the one on the right here. On the left, you have number 1 as the numerator divided by an absolute function of the original f of x. No transformation, just symbol f of x. And then you shift the rational function up by 5 units by letter D here. So to calculate this function, what you should do is identify 4 is the x and y is minus 2. So this function, this coordinate will become 4, which is no effectiveness for the x coordinate. It's just the same. So the coordinate x stays as the same as 4. However, the coordinate y will be of the function, which is minus 2 here, will be divided by 2. It's not divided by 2, but it will be inverse. So instead of 2/1 will become 1/2. And because we have an absolute value, so therefore instead of negative 2 here will become a positive 1/2, 1/2, and adding into 5. And as a result, the final coordinate will be 4, 5.5. Let's take a look at the next write example here. We will use the same point 4 and minus 2 coordinates to calculate the new coordinate undergone this transformation. Now make sure you notice these two transformations a little bit different, right? So here is a reciprocal function with the numerator as 1 on top, and down here we have a function f of x at phi inside the absolute value. So this phi is outside the absolute value and stand behind, but this 5 is the denominator itself. So the solution will be 4 stay the same as the x coordinate, but comma, the y coordinate will reverse 1 over 2, 1 over minus 2, add phi, and this number is still inside the absolute value. So minus 2 at phi result in 3, and therefore the y coordinate become 1 over 3. And the x coordinate is 4. So that's how we calculate a new coordinate. Let's take a look at the next example. Transformations apply to a rational function and absolute function. Given the point a and minus 6 is on the graph y equal f of x, determine the point of a new y as y equal 4 on the top divided by f x plus 1 and then minus 7 stand right beside it. So the solution will be 8 minus 6 transferred to 7. Now why do we have a number 7 instead of 8? The reason because if we look at the function notation here, x plus 1 means the x coordinate move to the left by 1 unit, and therefore we take 1 unit away from 8 and it becomes 7. And then comma, now we're talking about the y coordinate minus 6. So what happened to the minus 6? First we will inverse the function. Instead of 6 over 1 will become reciprocal 1 over 6. But because we have a factor 4 on the top, which is the y will be stretched by the factor 4. So the 4 here actually stands for letter A. So we multiply 1 over 6 by 4, it becomes 4 over 6 in the absolute value of the denominator. So this, if we calculate it, reduce the fraction, when we take it out, will become 4 over 6. Then we reduce it, become 2 over 3. And then 2 over 3, we take away minus 7. So the result will become minus 19 over 3 if we calculate it, the new y coordinate. So here I explain 1 over f of x undergone 1 over f of 7. Now f of 7, because this 7 is the x coordinate, take away from 1 coordinate. So the denominator down here is the y function of the new x coordinate. So this is 1 over x plus 1, and then this function will multiply with 4 and take away 7. So here, understand like this, the new function is. This is another explanation. Just make it look a little bit pretty to attract your focusing. So in the next video, I refer back to the old video I was performing to show you on the screen about the lecture video. I was talking about the transformation of the function, and I show you how to have the graph. And the question asks us to sketch let's say this is the first sketch.
So this is the
And this is
review
the
a little
second
bit
sketch.
for what you have learned and
So it
reconnect
wants us
to this
to
PowerPoint
get this
presentation.
function minus f minus x. Before we doing the sketching of this, we have to realize what is the type of transformation here. Are we sketching the vertical stretch or horizontal stretch or the shift left or right, move up or down? So we have to know the function notation to relate it to what type of function we're going to sketch here. Okay, so let me talk a little bit about the notation of the function. Now, if you register in my course, I will upload on the materials online, and you will have the access to all the beautiful MS PowerPoint presentation. And
So I just let you reconnect back to my own video before when I was teaching about this transformation and show you how to sketch from the beginning of the unit. In this PowerPoint presentation, we go a little bit deeper in terms of calculate of the coordinates, new coordinates. So the next transformation will be another example here, transformation applied to a rational function. So let's say we use the same coordinate 8 and minus 6 is on the new transformation now. Now in this transformation, the denominator down here is include the number 7. It's not the outside anymore like the previous slide. So the previous slide is show you okay, so I cannot go back by some reason, but anyway, so this is a new example even though we use the same 8 and minus 6. So let's see how we calculate this. Now we know that our x coordinate will have a reflection, that's why we have a negative in front here. So therefore the positive 8 become minus 8. But because we're not moving left or right, so we're not adding into anything, so it's just minus 8. And then for the y coordinate, we put a comma here and we talk about the y here. So our y will be reversed 1 over 6, but this minus 6 will be calculate inside the absolute value. And because in front of the y function we have a factor 4, so we multiply number 6 here with 4 and we take away 7. So 4 times minus 6 become 24. 24 minus 24 with minus 7 will become minus 31. But remember, after this we will take out the absolute value, so become 1 over 31. So in here I remind you about we have to perform the transformation in the order. So first order will be inverse or reverse x and y if the notation stated. The number 2, we pay attention to absolute or reciprocal. Number 3, we do the reflection on the x or y first, and we combine with the vertical or horizontal expansion. Then the last order will be vertical or horizontal shift. So just like the order of operation in the elementary you learned, we do multiply and divide before we add and subtract. So here is similar. We have to do multiply or divide the vertical or straight factor or the horizontal straight factor before we move left or right. So this very much follow the order of operation we learn in the elementary. So next, let's have some fun look at this picture below. So this is just for you to refresh your mind a little bit. So we see this image. So we know that our wound performs transformation on the times. Each object is translated on your desk, in the house, and our societies are constantly changing, transforming from agriculture to industrial world and then to digital world where we are right now. We are expecting one day we can land on the Mars planet. So it's just for fun, a food for thoughts. So the next slide, I'm talking about the summary of all of this, and for this you can read it on your own, and I don't have to do with you. So again, I'm talking about the order rules here. We do inverse, reverse, X and Y coordinates first, if any. We do absolute or reciprocal function, if any, and then vertical and horizontal expansion and compression, vertical and horizontal reflections, vertical and horizontal translation is the last step. Okay, so I cannot resume it. So the video you can watch on your own, and I also upload this video from your lesson plans. So the last slide, I give you the question, and if you want to know more information, you will visit my mathteaching.ca, or you can purchase my math courses online from http mathcourses-online.teachable.com. So this is the website of our school, and I hope that you will enjoy our online learning journey and enjoy this beautiful presentation. Thank you for watching, and bye for now. So I would like to show you a little bit about the video, and actually I would like to incorporate this video into our to my PowerPoint presentation. And because this is the video related to the transformation of coordinates, and I show you directly on the board how to sketch it. So I would like you to watch this video as well. So let's watch it. Welcome back, everyone. I am really happy today to show you another lesson in my pre-calculus Math 12 in the unit 1 of the lesson 3 and 4, which is transformation of the coordinates of the function and how to sketch them. Now, there are a lot of transformation, and I have present the transformation of the coordinates and show you how to find the coordinates undergone the transformation in my MS PowerPoint presentation. However, I would like to show you one more video how to sketch the transformation of the function. Now, I'm not be able to show you on sketching as I have shown you in my PowerPoint presentation, but I would like to show you at least how to calculate the coordinates, how to sketch the transformation by 2 or 3 examples. So I hope. Okay, so I cannot read this. think that I hit something and it, so sorry about this. Let me go back. Sorry for the technical accident. And because I don't want to re-record again, so I have to make an excuse for my mistake. Okay, so I cannot. Welcome back, everyone. I am really happy today to show you. I hear one more information I haven't included in here, which is could have a reflection over the x-axis with the negative in front, as well as reflection over the y-axis. So you can see that if we combine all this transformation, it looks very complicated, isn't it? So now let me show you to sketch a simple one first, and then I will show you to sketch the next more complex one. So now let's get this transformation here. Now, first of all, to sketch this, I should factor out the numerical in front of the letter X here. So let me factor it out. Actually, in this case, I don't have to factor it out, right? Because we don't have any negative or we don't have any things, so it might be interfere and make us make an error. So in this here, we don't have to. But let me tell you how we're going to sketch this function. Now, if you just look at this and guessing how the x-coordinate compress and y compress is very hard. But make sure that we do the good job and we do the accurate. We do it in accuracy. So how do we do that in accuracy? The only way to do it in accuracy is make sure that we have a coordinates, right? And we calculate the coordinates appropriately. So let's pick up a base point from the coordinate here. So this is the original. So I'm going to mark this base point, right? So the x here is 1 and the y here is 1. Now this base points symmetry, so it will be -1 and 1. And this is 0 and 0. This is the important point as well. These base points produce the shape of the image, right? And the x-intercept here is important, so I'm going to mark this as -2 and 0. So we base on these base point 1, 2, 3, 4, and we sketch them for the new image. So now let's first identify what type of transformation. This transformation here is horizontal expand, right? Because we have actually sometimes I a little bit confused in terms of we use the word expand or compression. But let's see the image and then we will decide it our okay. So let's say this is horizontal, right? So we're going to multiply any coordinate x by the, so let me just say expand first, okay? By, and if the image doesn't look like that, we can change it later. So let's just here just say horizontal expand by 1 over b, and 1 over b, our b is 1/2.
So 1 over 1/2 is become 2. So now we know that our x-coordinate will expand, instead of 1 will become 2. Instead of 2 will become 4. Instead of 4 will become 8, something like that, right? So now let's mark a few coordinate points and we will sketch this graph. So our base image is, let's start from here, -2 and 0. The next one will be 1 and 1, -1 and 1. And the next one will be 1 and 1. And actually, I forget the 0 and 0, which is important. And the next one will be 1 and 1. So these are the base points. And we're going to calculate our coordinate based on this transformation. So I'm going to say this will transform to horizontal expand by a factor of 2, because instead of 1/2, remember we have reverse, do 1 over b, so that is 2. So -2, and we don't have a negative in front, so we're not worried about reflection or anything. We also don't have an a here in front, so we're not worrying about the vertical expand. It's just horizontal expand in here. So here will be -2 times with 2 will be -4. And the side will be the same because we not reflect it, right? So we're not going to switch in the side. Whatever the side is supposed to be the same. We just expand it by a factor of 2, 1 over b, which is 1 over 1/2, which is equal to. So we multiply this with 2. -2 times 2 is -4. Now, the 0 is, we're talking about, this is x and 0 for y. So here in this transformation, we have a letter D, which is +1, which it will shift up the graph by 1 unit. So any y coordinate will move up by 1 unit. So our y0, when it move up, you add into 1, so it becomes 1. Now this form will be -1 times 2. So again, it will be -2. And 1 here is y. We add into the letter D, which is here 1 unit. So 1 add 1 is 2. The next coordinate, 0. If 0, we multiply with 2, it stays as 0. Now for y, 0, we move up to 1, so it becomes 1. This last coordinate, if it is a 1 for x, we multiply with factor of 2, so it becomes 2. And our y is 1, adding with 1 here, so it becomes 2. So now let's put in the point, plot the points, and we shape the graph. So we remember this is our new graph, right? So this is new y, our new y in this column. So we follow this, -4 and 1. 2, 3, 4. -4 and 1 right here. -2 and 2. -2 is here. And 2, so 1 and 2. So it's right here. 0 and 1. 0 and 1, so it's right here. And 2 and 2. So 2 and 2 is here. So let's see how I'm going to shape this one. So obviously, we know that this shape will be connecting like this. And this is the circle, look like an arc, right? An arc circle, like a circle. So it go like this, and it go like this. Now, this is the last one. Now I should mark one point here more. So this base point. Let's say this is 3 and 1. So let's do one more. 3 and 1. And how do we change 3, 1? 3 times with 2 will become 6. 1 add to 1 will become 2. So this is 1, 2, 3, 4, 5, 6. So our 6 about here. And our 1 is, our 2 is the same level. This is 2. So it's like this. So that is the shape we expecting to have it. And undergone this transformation, you can see obviously I use the word expand. I don't want to use the word compress because this factor, even though small, but because we reverse, so we expand, actually the image become horizontal expansion. It large in a horizontal way. So I use the word expand is accurate. Now sometimes because the language in English and my language is reverse, right? If we say expand, they say compress. If we say compress, they say expand. Usually sometimes it reverse like that. Not all the words, but my language is very like opposite, like in the reverse with the English words. So sometimes I have to be careful in terms of translating. So anyway, so now I read in the textbook. I saw some of the textbooks stated like horizontal compression of a factor 1/2 or something like that. And for some teachers, right, I can see that they translate it in the way that, and that's why sometimes myself is a confusion for me. So I just want to make sure that I use the correct word. Now, to my opinion, this is the expansion of the horizontal. It's not compressed. Even though the factor is compressed, right, it 1/2, but because we reverse it. And the image, final image show us is the expansion of the x-coordinates. So I use the word expand. That's my decision. Okay. So this is horizontal expand of a factor of 2. Now maybe it's awkward a little bit because this is 2. So actually it's true, but because we have the fraction which is small and we say expand, so it contradicts, right? But anyway, because we reverse, so I don't know. It's up to your choice. So if you hear any other teacher call this is compressed by a factor of 1/2 or whatever, you know what I mean. Okay, so sometimes the English language is a little bit confusing. Like, I don't know, to my language perspective of my language is reversed with whatever my language say. Okay, so now I have shown you how we get the RAP easily based on the transformation. Now let's do this one. This one is very complicated, right? So let's first identify the transformation first. So how do we identify? Now instead of say vertical, now I'm going to just say A, right? And based on this formula, we know this A we're talking about, right? So this is vertical and we have a reflection as well. So minus A equal -2. So keep in mind, we have a negative in front, which is including the reflection. And our B, hold on, I'm sorry. Before we do this, let me factor out this because this is the complex expression. So I'm going to factor it out first before I'm going to do anything. So now I'm going to factor out y equal -2 f. I'm going to factor out big square bracket and I put -1/2 outside. Inside I have an x. And because I factor out this -1/2, so this -1 affected by this factor. So instead of -1, I should put +2. And you see that it changed the transformation, right? Because 2 divided by 2 give you back to 1. So when I factor, I make sure that I change it in the way that it's the same like the original, right? So -1, but I change into 2. 2 divided by 2 will become 1. Now, the sign original is negative, right? This is the original form written -1. And you want this sign to be plus, because when you tie this minus with plus, it will become minus like that. So be careful in terms of the sign and notation, something like that, right? Okay. Now, so this is -2 in front of this expression. But let me see if let me check the bracket here to see if we cover the whole thing or it's just this one. So give me 1 second. Sometimes we got to be careful about the way they write, right? Okay, so that's correct. They just put the bracket in front of this group. So if they put the bracket like that, then we have to tie -2 to here, right? That's what I mean. But when we don't have the bracket cover like this, it means the letter D doesn't change. So we just shift up by 1 unit, okay? So now let's calculate the coordinate. So again, I'm gonna mark these base point coordinate again, right? So I'm gonna follow this exactly the same. So the first point will be -2 and 0. And the second point will be -1 and 1. So these are the base points. And the third one will be, I'm going to put here, okay, 0, I put here, 0 and 0. So that's third one, which is point here. The next one will be 1 and 1. And the next one will be 3 and 1. Okay, so let's check. So from this point, we're going to identify. So let me show you the transformation first, right? So we have a reflection on the axis, followed by the expansion of the factor 2 for the y-coordinate. We have a reflection on the y-axis because this negative sign, followed by the expansion of the x-coordinate by a factor 2. Then the x-coordinate will be shifted to the left by 2 units, and the whole function will be shifted up by the y-coordinate will be shifted up by 1. So that's how we identify the transformation. So now we're going to change this, right? Follow the transformation. And because this is a complex expression as well as a transformation, so the best way to do it accurately and correctly means we got to follow the order of operation. The same like in elementary, you learn the order of operation. Here we follow the order rules of transformation. So the order rules say we should do expand of vertical and reflect it, right? Now, the reflection and the expansion can go the same with the order. And you can do the vertical first and then horizontal, or you can do the horizontal first and vertical. But the shifted left or right and up or down have to be the last transformation. So we follow the order like that. So it sounds like complicated, right? So a lot of memorization, like any subject we have to memorize at some point. We have to know the rules, we have to follow the order. And practice keep perfect. Okay, so here, let me explain it to you. We have x coordinate. Now do you remember x first and then y, right? So -2. So now let's talk about vertical, which is the y. So when I multiply the y with 2, so the y here is 0. When you multiply with 2, it doesn't change. Now the x coordinate, we haven't talked about it, so still stay the same. Now the 0 times with -2 doesn't matter, still a 0. However, you got to add it to 1 for the y coordinate, right? Because we shape it up like this. So that is the first transformation. So let's talk about the first one. Now it undergone another transformation, which is reflection over the y-axis. So the negative, because reflect will be reversed, and also expand by a factor 2. So we multiply -2 with 2, which is 4, but we have to do the reflection. So instead of -4, we just twist the side, become 4. Now we're going to subtract this by 2 units. So 4 minus 2, and that for x. And for y is 0. And we shift up 1 unit. Yeah, because the 0 here, when you multiply with -2, it's just the same, right? And then you shift up 1 unit. So that's the answer. And the final answer calculate is 2 and 1. Okay, now let's do this one. So the first transformation, we're talking about, now we can do the x first and then do the y, it doesn't matter, right? So -1 will time with 2 will become 2. However, because reflection, so instead of negative will become a positive. So 2, then you have to subtract the 2, right? And the 1 you time with -2, so it becomes -2. So the y coordinate here time with -2 here because the factor of the expansion. So 1 times -2 follow the reflection as well. So it will become -2. So the final transformation point will become 2 minus 2 is 0 and -2. -2 should be adding with the 1 here, so it become add 1 as well for the y. So the y coordinate will be y1 times -2 is -2. -2 add 1, right? So will become -1. So that's the last final result. Now let's calculate this point. This point will be 0 times with -2, which is 0. And then subtract, shift to the left 2 units, so subtract 2. So this becomes -2. And the 0 for y times with -2 here, the factor of expansion of a, 0 times -2, which is 0. 0 adding to 1, so it becomes 1. So now, the next point, x is 1, we're going to time with -2, so become -2. -2, add -2, right, because we shift 2 units to the left, so we subtract 2. So 1 times -2 is -2. -2 -2 is -4. And 1 here for y times with -2 will be -2. minus 2 add 1 will be minus 1. And the next one, the x here is 3, right? Time with minus 2 will be minus 6. It means I including the reflection, right? Because the sign. So 3 minus 2 is minus 6. Minus 6 minus 2 will be minus 8. And 1 here will multiply with minus 2. So become minus 2. Minus 2 add 1. So minus 1. So let's plot this point here. Remember, on the right side is our new y, right? Transformation. So the first point, minus 2, 0, becomes 2 and 1. So let's log that. Will be 2 and 1. So that's the point. The next point is 0 and minus 1. So 0 and minus 1 is just 1. The next point is minus 2 and 1. So minus 2 and 1, so this point right here. And minus 4 and minus 1. So minus 4 and minus 1 is down here. Minus 8 and minus 1. So this is 4. So the A have to be all the way this way. And minus 1. So something like that. So now let's sketch it. Okay, do I miss any point? Okay, so we realize that this is the reflection over the y-axis, right? So it looks like this way, right? As you keep going, and one. Did I miss anything? Okay. We gotta be careful about the way we shape it, right? Let me see. Okay, so let's follow the order. So we're talking about minus 2 and 0. So we start from this point, and thus become 2 and 1. So I have to mark the order, okay? So this is the first point we're talking about. So this is the first point we're talking about. Become 2 and 1. The next point we're talking about minus 1, 1, which is this point, is the second order 2. So become 0 and minus 1. So this is 2, right? Second order, 0 and minus 1. Now the third point is 0 and 0. 0 and 0. So this is the third point. 0 and 0 become minus 2 and minus 2 and 1. So this is the third point. And then the next point here is 1 and 1, which is the fourth point. So 1 and 1. 1 and 1 become minus 4 and minus 1. So minus 4 and minus 1. So that's number 4. And then the next one, the last one is number 5. Number 5 is minus 8. So this is number 5. Okay, so let's follow the order. So we start from 1. We start from 1. We connect to 2. So it looks like C1 and 2. So we have to connect this way. So let's analyze the image after we complete it. As you can see that if we talk about the transformation, we see that based on the circle, you can see that we have a vertical stretch. And that's why this short circle become a tall circle, because we have a vertical stretch. Secondly, we have a reflection. This circle is parabola is opening upward, because the reflection now is opening downward. So that's correct. The next reflection is reflection over the y-axis and horizontal stretch by factor 2. So you can see that by the shape, if we just look at the circle here, this is a narrow circle. This is enlarged circles by a factor 2. So yes, the horizontal expands, right? And also, we're talking about the reflection over the y-axis. So you can see that this linear on the left now become reflect to the y-axis, so become this line. Now this linear on the right, and we have a reflection over the x-axis, so it moved out. Instead of up here, it moved down here. And because it's reflection over the y-axis this way, so this linear on the right now become on the left. And what else do we see? So it's very much, we know that based on these notation and based on the order of transformation, we follow the rules, we create this image correctly. And therefore, because the math is detailed and a lot of information, so we have to make sure that we follow step by step, and we follow the rules of the order of transformation as well, so that we create the image accurately and in accuracy. So I hope that you enjoy my video. Thank you for watching, and stay tuned for our next MS PowerPoint presentation. Bye for now.
So this is a long video, and I hope that you will enjoy watching the whole thing from the beginning until the end. Now, the important here is I want to show you in details what the information we learn from our lesson. Are we talking about the coordinate transformation? How its complexities, right? Sometimes we have to stress, sometimes we have to divide by factor, sometimes we multiply by factor, and then we have to subtract and adding. So a lot of operation for one coordinates. However, this base point is very important. And I know this is a lot of information and details. However, we are online. It means that if you get bored, you can turn off my video, but then you will come back and rewatch and catch up with what you learned so far, so you don't miss on the information. So the more information, the more informative I provide to you, the better you are. The better you are learning. Thank you for watching, and bye for now. Our next lesson will be about the radical function.